Hello. In this short movie, we will look at the first prize, Nobel Prize for the subject of physics from 1901, as you can see, given to Wilhelm Röntgen, and we can see that it was in recognition of the extraordinary service he has rendered by the discovery of the remarkable rays subsequently named after him. Here you see a picture of his laboratory in Würzburg, where he made the discovery. From the official Nobel Prize site, the part on work, this is the official description why he got the prize. It's a quote. In 1895, Wilhelm Röntgen studied cathode radiation, which occurs when an electrical charge is applied to two metal plates inside a glass tube filled with a rarefied gas. Rarefied, it means that it is almost a vacuum, but not quite. There are two plates. One is connected to a plus from an accu, for instance, or a battery, and the other pole is connected to the negative side of the accu or the battery, and the radiation is coming from the negative pole. Cathode is negative. Although the apparatus was screened off, he noticed a faint light on the light-sensitive screen that happened to be close by. So that means that there was some kind of ray coming out of the plate, traveling through the tube with the gas in it, and hitting on the other side the screen, which then reacted by giving a light. Further investigations revealed that it was caused by a penetrating, previously unknown type of radiation. X-ray radiation became a powerful tool for physical experiments and examining the body's interior. Röntgen himself called it X-rays. Many other people called it Röntgen rays, but he was too shy and too modest to use the name himself. Here you see that the discovery was immediately applied in medics. You see here Röntgen rays are used to find a bullet in probably the skull of this person. And you see that this photograph is taken in 1897, and X-rays were only discovered 2 years earlier. So that was immediately applied. From the biographical part of the Nobel Prize site on Röntgen, you see Röntgen's name, however, is chiefly associated with his discovery of rays that he called X-rays. In 1895, he was studying the phenomenon accompanying the passage of an electrical current through a glass of extremely low pressure. Yeah, so almost no gas in it, but just a little bit. Previous work in this field had already carried out by, well, you see here J. Plucker, J. Hittorf, C.F. Farley, E. Goldstein, William Crookes, H.H. and F. von Leonard, all famous physicists. And by the work of these scientists, the properties of the cathode rays, the name given by Goldstein to the electric current established in highly rarefied gases by the very high tension electricity generated by a Rundorf induction coil. Yeah, I just said it was a battery or an accu, but indeed, most of the time, Rundorf coils were used. If you don't know what it is, you can go, for instance, to Wikipedia, and you can see there's a page on it. Well, this discovery became well known. Röntgen's work on cathode rays led him, however, to the discovery of a new kind of rays, named after him, but he himself called them, as I earlier said, X-rays. Okay, we continue. On the evening of November the 8th, 1895, he found that if the discharge tube is enclosed in a sealed, thick black carton to exclude all light, so no light can get out of the tube, and if he's worked in a dark room, a paper plate covered on one side with barium platinosinide placed in the path of the rays became fluorescence, even when it was as far as 2 meters from the discharge tube. So this means that the rays are not only in the tube, but they're actually coming out of the tube, even as far as 2 meters. That was never seen before, of course. During subsequent experiments, he found that objects of different thicknesses interposed in the path of the X-ray showed variable transparency to them, when recorded on a photographic plate. Well, we all know the famous example of bones. Bones do not let the rays through, while muscles and skin does. Everyone has been x-rayed probably once or more often in his life or her life. When he immobilized for some moments the hand of his wife in the path of the x-rays over a photographic plate, he observed after the development of the plate an image of his wife's hand, which shows the shadows thrown by the bones of her hand. They don't let the x-rays through. And that of a ring she has wearing. The ring made of metal also doesn't allow the x-ray to go through, but her flesh and her skin does. Surrounded by the penumbra of the flesh, which was more penetrable to the rays and therefore threw a fainter shadow. This was the first röntgenogram ever taken, and it caused a sensation. We will find that later in another movie, a second movie on the subject. You can also see the picture. In further experiments, Röntgen showed that the new rays are produced by the impact of cathode rays on a material object. Because the nature was then unknown, he gave them the name X-rays. Later, Max van Laue and his pupils showed that they are some kind of electromagnetic nature, from the same electromagnetic nature as light. Thus, in fact, they are light, but with some different properties, but different from it only in the higher frequency of their vibration and thus in their wavelengths and thus in their energy. X-rays have more energy than normal light. As you can see, this is coming from the biographical part of the official Nobel Prize site. Almost all information is coming from that site. Here you see another photograph of a Röntgen photograph. This is taken from the lungs. Well, if you are a doctor and you have studied for it, you can probably see whether this female is probably healthy or not. Specialized trait, of course. Every time when a Nobel Prize is given, there's also a ceremony and a speech is given always. And this time the speech was given by C.T. Oetner, and parts from it are quoted here. First part is skipped, and then you see the discovery of the so-called Röntgen rays, or as he himself called it, X-rays. These are, as we know, a new form of energy and have received the name rays on account of the properties of propagating themselves in straight lines as light does. So it was already clear, very fast, that Röntgen rays, X-rays, have a lot of similarities with normal visible light. The actual constitution of this radiation of energy is still unknown. At that time, of course, it's in 1901. Several of its characteristic properties have, however, been discovered, first by Röntgen himself, and then by other physicists who have directed their researches into this field. And there's no doubt that much success will be gained in physical science when this strange energy form is officially investigated and its wide field thoroughly explored. Well, that's true. And there are more Nobel Prizes given for this type of research later. Let us remind ourselves of but one of the properties which have been found in Röntgen rays, that what is of the basis of the extensive use of X-rays in practical medical practice, and it is many bodies, just as they allow light to pass through them in varying degrees, behave likewise with X-rays. But if the difference, that some which are totally impenetrable to light can easily be penetrated by X-rays, while other bodies stop them completely. Now, for example, metals are impenetrable to them is the X-rays. Wood, leather, cardboard and other materials are penetrable by the X-rays, and this is also the case with the muscular tissue of animal organisms, but not the bones. Now, when a foreign body impenetrable to X-rays, for instance a bullet or a needle, has entered these tissues, its location can be determined by illuminating the appropriate part of the body with X-rays and taking a shadow graph of it on a photographic plate. We just saw that a few slides ago with the bullet, whereupon the impenetrable body is immediately detected and thus can be removed. The importance for this practical surgery and how many operations have been made possible and facilitated by it is well known to all, even in 1901. If we add that in many cases severe skin diseases, for instance lupus, have been successfully treated with Röntgen rays. They will come back to that. There's a Nobel Prize for that too. We can say at once that Röntgen discovery has already brought so much benefit to mankind that rewarded it with the Nobel Prize fulfills the intention of the testator to a very high degree. Or again, taken from the official site. Here you see a modern X-ray machine. This is the patient. This is probably the X-rays are made, and probably they are collected here under the patients, of course. Well then, perspective, this light, a helping hand from the media. As I said before, the discovery was a sensation. Here we can follow it. The world first discovered the sensational news that Wilhelm Röntgen's mysterious X-ray could penetrate clothing and human skin was not through scientists but through the press. Röntgen's accidental discovery of X-rays sparked a media storm that meant his findings would have an impact like no other had before it. Röntgen did write an article on X-rays and discoveries and sent it to 90 colleagues. 12 of the envelopes addressed to friends or to discuss scientists like Lord Kelvin also contained 9 photographs. You can see them in the next movie. Röntgen made several photos, mainly of the interior of metal objects, but there was also another photo that led to the situation in which all hell broke loose, as Röntgen would later complain. He didn't like the attention. Since X-ray could penetrate materials like metals and wood, it seemed natural to find out if they could penetrate flesh. What Röntgen discovered was a remarkable ability to see through flesh and bones visible. To illustrate this defect, Röntgen took an X-ray photograph of his wife's hand, which produced an almost ghoulish image that clearly showed her bones and her wedding ring, and that caused a sensation. Via Franz Eckner, a student, and Ernst Legger, a college professor, that photos reached Legger's father, the editor of Die Presse, that's the largest paper in Vienna at that time, who published an article about the discovery written by Ernst Legger, that was his son thus. Legger's X-ray story appeared under the headline, A Sensational Discovery. Describing the potential of his new discovery, the article said, if you let the inventions run freely, this could be of immeasurable help for diagnosis and countless diseases. The story was picked up by other papers, first in January and later in the UK, and the world followed, and of course, mainly thanks to the photographs. Only after the general public, the scientific communication picked up discovery, it was very soon used to diagnose all kinds of illness and injuries that we have seen already. The reaction to Röntgen's X-rays made him an instant celebrity. Many hours were bestowed on him, suites were named after him, and Röntgen received countless honorary doctorates and prizes. But Röntgen himself had little to do with any of this. He published only 2 more papers on X-rays, and apart from one public lecture in Würzburg, he declined all offers for public lectures. As he said, he didn't like the attention. Again, this is come from the official site. Well, as the last picture you see here, a modern version of the X-ray machine. This is a CT scanner which works with X-rays, and you can see it's three-dimensional, but here you have the source of the X-rays, and it can make a 360-degree turn, so it can look from any direction. So you can get a 3D picture. Okay, this is the end of the first movie on this discovery. There will be a next movie, and it will be on the lecture about this subject. And it will be there next week. Thank you for watching.